Hello everyone, my name is Terry with terrythetutor.com, and today we are going over parallel and perpendicular lines. This is a topic that is often thought to be harder than it really is by students, so I'm here to alleviate some of your stress. First, I'm going to list the rules for parallel and perpendicular lines so that we can differentiate between them. Parallel lines have the same slope. Okay, you can read that there. Perpendicular lines have opposite reciprocal slopes. What does that mean? If they have the same slope, that's pretty easy. But opposite reciprocal. Well, let's do an example real quick. Let's say I have the line, just making up this line as I go. Y equals 14 over 5, negative 14 over 5, x plus 3. Okay. And I have also got another line, y equals 5 over 14, x plus 11. Well, they are opposite because they're not the same sign. Opposite refers to their sign. Negative, positive, I guess positive. And reciprocal means that, let's say, well, it's really just the idea of flipping the fraction. Flipping the fraction. Some of you might be saying, well, okay, Terry, that's good and well and all, but what if I have y equals 4x plus 3? What is the reciprocal of that? Well, that's simple, my friend. That is 4 over 1. I bet you didn't remember that rule. Well, it is. It's 4 over 1. So the reciprocal, well, let's do the negative reciprocal. The negative reciprocal would be negative 1 over 4. Let's make up another number, plus 6. So if you see the slopes, even if it's a whole number, it can become a reciprocal. It can be reciprocated. Parallel lines, I'm sure you can imagine they are the same slope. M equals 4, 5, M equals 5. Nothing special there. So we've got a set of instructions. Determine whether each pair of lines is parallel, perpendicular, or neither. Probably should be R, or whatever. So I'm going to go ahead and take a look at this one first. In order to determine if they're parallel, perpendicular, or neither, what am I looking at again? I'm looking at their slope. And I remember from a previous video we went over slope-intercept form. Y equals mx plus b, where m is the slope of a line and b is the y-intercept. Hence why it's called slope-intercept form. Okay, so it looks like these match. We've got plus, here's my b, here's my y, that matches up, there's the x. So what's the slope? Well, the slope is 12. And it just so happens both of them have the same slope. So if they have the same slope, we can call them parallel. And just so you can see what a parallel line looks like, what two parallel lines look like, let's draw this graph, the Cartesian coordinate system. And we are going to draw parallel lines. Let's say we've got a line going like that, and another line going like that. Those are parallel. So are these lines. So are these lines. These lines, oh, that's green again. I wanted red. These lines are also parallel. They have the same slope. In fact, well, yeah, that's really all there is to it. Same slope, they're parallel. Now let's go ahead and take a look at the next example. Okay, I'm gonna be fair with you guys. I had to get up real quick. I heard someone talking. And I don't remember what was going on. But I believe I was right here. Okay. So it looks like we have one of them in slope-intercept form, as we did before. Slope-intercept form. Well, referring here, slope-intercept form. And we have another one that we need to put into slope-intercept form so we can observe its slope. As you can tell, this one's slope is negative 1/3. Let's go ahead and write that down right now. Negative 1/3. But now I need to solve for this one, and I need to find the slope of it. We can undo this rise over run thing where I pick 2 points and I make it a lot harder than it needs to be. Or I can solve for y, which is putting it into slope-intercept form, and pull the slope from there. And that's what I'm going to do. So in order to solve for y on this equation, I'm going to add 9x to both sides. So I get 3y equals 9x minus 12. Beautiful. Now let's divide both sides by 3. Divide by 3, divide by 3. So I've got y equals 9 divided by 3 is 3. So I've got 3x minus 4. I can pick out the slope. The slope is 3. For this one, the slope is m equals 3. So are they parallel, perpendicular, or neither? Well, they're opposite, and they're reciprocals. This is 3 over 1. So they are perpendicular. Perpendicular. And you've got an A on that question on the test. This one's a little bit more challenging. Given the points that the line passes through, determine if the lines are parallel, perpendicular, or neither. We have a line passing through the points 0, 2, and 14, 8. And we have another line passing through negative 2, 0, and 12, 6. So the first thing we got to do is we have to find the slope. The same thing we've been doing. If you notice before, we got it into slope-intercept form, only to look at the slope, not the y-intercept. So in order to find the slope, we can do rise over run. Or, if you know this formula, y2 minus y1 over x2 minus x1, that's another formula for slope. This is also rise over run, because y values are rise, x values are run. And this is m for slope. So I'm going to pick one point. Okay, this is going to be x1, y1. It's going to be x2, y2. I'm going to go ahead and plug it into my equation, this little formula right here that I have. And I've got 8 minus, what is y1? 2 over 14 minus 0, which equals 6 over 14, which equals 3 over 7. Okay, that's our m for this line. Now let's do it for the other one. So let's go ahead and label our points, x1, y1. You don't have to do this, but it's a good way to visualize what's actually going on. So, x2, I'm silly, y2. And now let's do the formula again. So I've got 12, no, that's x2. Let's do y2 minus y1, of course. Got 6 minus 0 over, and I've got 12 minus, and it looks like this is going to be negative 2. 12 minus negative 2 equals 6 minus 0 is 6, and 12 minus 2, well, that's simply saying plus. So I've got 14. 12 plus 2 is 14. And I wind up with 3 over 7. Ah. do these lines have the same slope? They do indeed, so they are parallel. Now, I didn't give an example like this, but if for whatever reason you had something like 7, you had one line that had the slope of 7, and you had another line that had the slope of 1 over 7, these would not be perpendicular. These would be neither. Seeing them being perpendicular makes you want to say that. They're not perpendicular. Seeing that they're reciprocals makes it easy for you to want to assume that they're perpendicular, but they're not. They're not perpendicular because they're not opposite. They have the same sign. And that's a curveball that may or may not be thrown at you. Alright, if you have any questions that you'd like answered by me, you can submit your questions to Terry, myself, at terrythetutor.com for a very small fee of 99 cents. Thank you.